Natural resource cycles: water, soil, air. Understanding how natural resources cycle through ecosystems is essential for environmental stewardship. These cycles, water, soil, and air, are interconnected, influencing everything from climate patterns to plant growth and biodiversity. The water cycle and its influence on local ecosystems. The water cycle, also known as the hydraulical cycle, describes how water moves through the Earth's atmosphere, surface, and underground. It consists of several key processes: evaporation and transpiration. Water from oceans, lakes, and rivers evaporates due to heat from the sun. Plants release water vapor through transpiration, contributing to atmospheric moisture. Condensation. Water vapor cools and forms clouds as it condenses into tiny droplets. This process helps regulate temperature by storing heat in the atmosphere. Precipitation. Water returns to the earth as rain, snow, sleet, or hail. The amount and type of precipitation determine local ecosystems. Example, rainforests versus deserts. Runoff and infiltration. Water that does not soak into the soil flows into streams, rivers, and oceans. Runoff. Some water infiltrates the ground, replenishing underground aquifers. Effects of the water cycle on ecosystems. Droughts disrupt plant and animal life, leading to desertification. Floods reshape landscapes and distribute nutrients, but can cause erosion and habitat loss. Groundwater depletion from overuse lowers water tables, harming wetlands and agriculture. Human impact on the water cycle. Deforestation reduces transpiration, altering rainwater patterns. Urbanization increases runoff and decreases water absorption, leading to floods. Pollution from agriculture and industry contaminates freshwater sources. Conservation strategies. Protect wetlands that act as natural water filters. Practice sustainable agriculture to reduce water contamination. Restore forests to support healthy precipitation cycles. Soil formation, erosion, and nutrient cycling. Healthy soil is the foundation of plant growth and ecosystem stability. Soil formation and nutrient cycling ensure that life can thrive by providing essential minerals and organic matter. Soil formation. Soil develops over thousands of years through a combination of weathering of rock. Wind, water, and temperature break down rocks into smaller particles. Decomposition of organic matter. Dead plants and animals decompose, enriching the soil. Microbial activity. Fungi and bacteria break down organic material, releasing nutrients. Soil is made up of different layers. Topsoil, humus layer, rich in organic matter and nutrients, supporting plant life. Subsoil contains minerals leached from the topsoil but has less organic material. Parent rock, the base layer from which soil forms over time. Erosion and its consequences. Soil erosion occurs when wind, water, or human activities remove topsoil faster than it can regenerate. Causes of soil erosion. Deforestation. Tree roots bind soil. Their removal exposes soil to erosion. Overgrazing. Livestock strip the land of vegetation, leading to barren soil. Agricultural mismanagement. Monocropping and excessive tilling deplete nutrients. Consequences of soil erosion. Loss of fertile land, reducing crop yields. Increased sediment in rivers, harming aquatic life. Desertification, where once productive land turns to desert. Nutrient cycling in soil. Soil nutrients cycle through ecosystems supporting plant and animal life. The most important cycles include nitrogen cycle. Bacteria convert nitrogen from the air into a form plants can use. Phosphorus cycle. Rocks release phosphorus into the soil, where plants absorb it. Carbon cycle. Decomposed organic matter enriches soil carbon, supporting plant growth. Soil conservation practices. Crop rotation. Planting different crops replenishes nutrients. Cover crops. Growing plants in off-seasons prevents erosion. No-till farming. Reduces soil disturbance and preserves nutrients. Air quality, carbon cycles, and climate regulation. Air is a crucial component of ecosystems, affecting climate, weather patterns, and the ability of organisms to survive. Factors affecting air quality. Natural sources of air pollution. Volcanic eruptions release sulfur dioxide and ash. Wildfires produce carbon monoxide and fine particulates. Pollen and dust storms impact respiratory health. Human-caused air pollution. Burning fossil fuels releases carbon dioxide and other greenhouse gases. Deforestation reduces oxygen levels and increases CO2. Industrial emissions contribute to smog and acid rain. The carbon cycle and climate regulation. The carbon cycle controls how carbon moves between the atmosphere, plants, soil, and oceans. It is essential for regulating Earth's climate. Photosynthesis. Plants absorb CO2 from the air and convert it into oxygen. Respiration. Animals and plants release CO2 back into the air through breathing. Decomposition. When plants and animals die, their carbon returns to the soil. Combustion. Burning fossil fuels releases stored carbon into the atmosphere. Climate regulation. Increased CO2 levels trap heat, contributing to global warming. Forests and oceans act as carbon sinks, absorbing excess CO2. Changes in air composition influence weather patterns and ocean currents. Protecting air quality and climate stability. Reforestation, planting trees, increases oxygen and captures CO2. Reducing fossil fuel use, switching to renewable energy lowers emissions. Air pollution controls. Enforcing clean air regulations prevents smog and acid rain. Conclusion. Understanding the cycles of water, soil, and air helps us protect ecosystems and maintain environmental balance. When these natural processes are disrupted through pollution, deforestation, or unsustainable land use, ecosystems degrade, affecting both wildlife and human survival. By adopting sustainable practices like responsible water use, soil conservation, and carbon footprint reduction, we can work toward a healthier planet.